Thank you, everybody. So, I am really happy to be here again to do yet another talk at DevOps Barcelona. Let me introduce myself briefly. I am Horacio González. As you can maybe hear with my accent, I am a Spaniard who has been living in France for over 20 years. So my English accent combines the worst traits of both Spanish and French accents. Sorry about that. And now it is just after lunch, so my task is even more difficult. I must keep you awake for 45 minutes. I am the Director of Developer Relations at OVS Cloud. OVS Cloud, if you don't know us, we are a cloud provider. We are maybe smaller than the big one, like the American ones, but we are the biggest in Europe, and we are in the top 10 in the world. So next time you have an infrastructure to build, an application to deploy, have a look to our site. I think you will be surprised. And we are here to talk about Gophers, or about Kubernetes Operators. Let me explain. Last year, with my colleague Aurélie we did a talk here about creating a Terraform provider, and we did it live. So for this year, we submitted a sequel. We were going to do the same thing with a Kubernetes operator. But Aurélie couldn't come this year, so I am alone now. I must do the talk by myself. Wish me luck, please. And why Gophers? Because doing something so technical as a Kubernetes operator, it isn't visual enough, it is kind of boring, so I am going to do it in a more visual way. There will be a lot of Gophers, and of course, Gophers and Golang are very linked to Kubernetes, so it fits. Of course, all the drawings you will see will be mine and from my colleague, and they are all based in the Go mascot. Let's begin. One question before. Who here has already used Kubernetes? Can you raise your hands, please? Hey, it is better than some years ago. And who here has already done something with Kubernetes operators? That's even better. But half of you haven't touched Kubernetes operators, so let me try to explain in 10 minutes what are Kubernetes operators and why are they important. So, of course, Kubernetes is really nice when you have microservices architecture, you want to manage that to reduce complexity, to automate operations of microservice architectures. But if you have a lot of applications, lots of distributed services in your cluster, it is going to be complex. So yeah, you are going to automate a lot of things, but there is a complexity that it is going to go up. There are tooling that has been made in order to reduce this complexity. For example, there is Helm. It's a package manager for Kubernetes. It allows you to, in a single command, deploy a complex architecture or upgrade to a new version, roll back to a precedent one, etc. It's a solution for the first part of the problem, the deployment part. But in real life, operating something on Kubernetes is more than simply installing and upgrading. There is the whole lifecycle management. There is also getting metrics, actuating. There are all the things that a human operator does. And the problem is that all those tasks at the right, all those day-to-day tasks from the human operator can be very complex if you begin to put all your infrastructure on Kubernetes. So the idea behind Kubernetes Operator is Kubernetes is all about automation. You could try to automate the day-to-day task of the human operator and allowing Kubernetes to do all the whole stack, not only the install and upgrade. The idea is a Kubernetes operator is the Kubernetes version of the human operator. It isn't going to replace the sysadmin. It is going to replace the day-to-day, routinary, low added value task that the sysadmin must do in order to operate some kind of software on Kubernetes. And I say some kind of software because every operator is tailored to one kind of software. For example, there is an operator to help you to operate PostgreSQL on Kubernetes. There is another operator to help you operate Kafka on Kubernetes. So for every software, you can create an operator that it is going to be a Kubernetes version of the task the human operator needs to do. How can we build these operators? Well, we are going to build them using some base Kubernetes bricks. We are going to use a custom resource and controllers. Custom resource, we are going to see at the left, the puzzle pairs. It's a way to extend the Kubernetes API to allowing Kubernetes to modelize something it doesn't know yet. And the controllers, and you will see why I draw them that the eye of Sauron, they are going to look all the time to the state of the cluster and your to desired state, to the instruction you have given, and be sure that your instructions are implemented in the cluster. So let me begin. Kubernetes controllers. Kubernetes controllers are reconcile loops. Their work is looking at the desired state, the manifest, the instruction you have given to the cluster, and looking at the current state, what is currently deployed on the cluster. They do a difference and they act. And that's the interesting part. When there is a difference, they act in order to make sure that the current state is the most similar possible to the desired state. And every controller is specialized in a single thing. For example, there is a controller that is going to deal with the persistent volume in Kubernetes. When you declare a persistent volume claim, there is a controller who is going to go to get the persistent volume, to attach it to the persistent volume claim, and to mount it in the pods. That's the persistent volume controller. But you can create your own controllers for the software you want to operate. Custom resource definition, it is the way to extend the Kubernetes API. In Kubernetes, at the center, there is an API. Every Kubernetes concept has a reflection in the Kubernetes API. And this API is made to be modular. You can extend the Kubernetes API in real time, adding new definition, new Kubernetes objects. The CRD, the custom resource definition, is the template of a new kind of Kubernetes resources. You are going to explain Kubernetes, hey, I want you to modelize this. So, after that, you are going to be able to create new Kubernetes objects following this template. And you do it in YAML, of course. We are going to extend, we are going to add a new custom resource definition, and then we are going to be able to create new objects corresponding to this custom resource definition. The custom resource, they modelize something. For example, if we do if we are doing an operator to manage a PostgreSQL database, maybe we could create a custom resource definition to modelize a backup. What is a backup? It will be so properties, so when do you do the backup? Where do you put the backup? How do you test the backup? And those fields, you are going to define a new backup, a new backup to make daily, to put it in this S3 repository, and to test it with this command. So you create a new resource from type PostgreSQL backup. And a Kubernetes operator is mixing these custom resources and the controller in order to help you operate a software. The idea is in order to create an operator, you need to understand which are the tasks that the human operator does day to day, and then try to translate that into CRD and controllers. For example, let's go back to the database. So the human operator needs to do, they do backups every day. They are going to look at the disk use to be sure that we have still enough disk for the current day. They maybe, if the database begins to get too big, they need to do some sharding. Okay, so these are actions that my operator is going to implement. And how we implement that? For every action, we define the custom resource. So for the backup, I need to define a custom resource backup and a controller. How do I do the backup? And the controller is code. If you are going to say, in order to do a backup, you execute the PostgreSQL dump, that, and that. You encapsulate the operator task in CRD and controllers. And you have a new operator. Operators can be very simple or can be very complex. For PostgreSQL, for example, one of the best-known operators is done by a Spanish company called Stackgres. And their operator is very complex. It does lots and lots of things. But you can do a very simple operator. That is what we are going to do in this talk. How do you write them? Well, they are simple CRD that are written in YAML and a controller that can be written in any language because they are simply pods. Any container you can deploy on Kubernetes can do the controller role. So you can do it as you want. Of course, you can use something called the operator framework. There are a lot of shortcuts and full SDK. It is made to make simple building complex operators. But for a simple one, as we are going to do today, we are simply going to write some code and writing some YAML. It is enough. So for beginning, for understanding concepts, you don't need to do that. But when you are doing something more complex, you can use the operator SDK that has 3 possibilities. You can write your operators in Helm, in Ansible, or in Go using the operator SDK. So what I am going to build? A very simple Kubernetes operator where we are going to manage some cute Gophers because I am going to make it visual. And that's the odd part. I am not going to do it in Go because there is lots of boilerplate. And I need to go fast. So I am going to do it in JavaScript. But also because I want to show you that writing an operator, it is no dark magic. Some lines of code, easy to understand, and you will see we will have our operator. All the code I am going to do is available. I am going to get you the slide after that. It is in this repository. So we begin with a lot of drawings of Go by my colleague Aurélie from this repository. And I have created a container, random Gopher container. I have published it in the Docker Hub. It's a very silly container. It is only a small program that at a startup, when the container boots up, it gets the list of all the Gophers from Aurélie's repository, and it chooses one, and it exposes that Gopher. So if I deploy 10 containers, every one will have a different Gopher. And I have deployed it in my Kubernetes cluster. So I have deployed my random Gopher in 10 replicas. That means that in my cluster, They are 10 different pods, and every one has a different identity, a different Gopher. That's my baseline. I have in my cluster 10 pods. Up. So let's see that. kubectl get pods. Excuse me. No. If I have forgotten my kubeconfig, nothing is going to work. Yeah, I said I love doing live coding because it makes things more interesting, let's say. Yeah, let me simply delete the first version of the operator. We are going to write it again now. Delete deployment, Gopher operator, and we can begin. So, I have delete deployment, Gopher operator, and delete pod. I want to delete, yeah. I have my 10, and the other is terminating. It's not a problem for me. So, how can I see which Gopher every pod has? I could do a service, but the service will point in a random way to one of the 10 pods. I want to be able to see for every pod which is their Gopher. Well, an interesting way to do that is I can get the IP address of kubectl get pods in wide. And here I have the IP address of every pod. It is an internal IP address in the network, in the private network that Kubernetes used to put all their pods. So I cannot access directly from the outside. My operator will need to connect to that. But before writing the operator, I want to see if it is working. So I am creating a small pod, a busy box. Up. Let me explain. I am going to tell my Kubernetes, hey, Kubernetes, can you run in interactive mode, opening a terminal, a busy box? A busy box is a small Linux container, almost with nothing behind a shell. I want to create this container directly in the cluster and open a terminal. So I will be in a pod. I will be able to ask questions to the other pods. I create my busy box. Yeah, I am there. So now I could ask it to Gopher name. Okay. The get -qo. The first one in the port 8080, Gopher name. Sorry, what I have done now, qo. Okay, I have forgotten the command, silly me again. Okay, what I have done yet? Okay, I think I have forgotten a dash. Yeah, so the first is the Buffy Gopher. Okay, and the second one, or this one, for example, the 21. And the 21 is the Gandalf Gopher. Okay. So I have my pods. I know how to ask them which Gopher they are. First step is working. I also have an API, an external API. I have deployed it in a public cloud instance, completely outside my cluster. It's a normal CRUD API. You can add Gophers, you can delete Gophers, you can modify Gophers, and you can get Gophers. So what I would like is to tell my Kubernetes clusters, hey, when I deploy a new random Gopher pod, I want you to send a message to the API to show in the API what are the Gophers that are currently deployed. Because with my API, I also have a very sample interface showing the Gophers that are currently deployed. So the idea of my controller is simply that. I am going to create a controller that is going to get the information of all the Gopher pods that are currently deployed in my cluster, and they are going to send the information to the API. Very important thing here. Kubernetes operators are really useful because you are unlimited to the resources of your clusters. You can use them to manage from your Kubernetes clusters resources that are outside the cluster, like my API here. Okay? As I told you, I am doing it in the simplest way, in JavaScript. Why? Because I only have 25 minutes now. We need to go fast, and I want you to understand easily what I am doing. You could do it in Go. You will have more boilerplate. You could do it in Ansible. I couldn't, because last time I did Ansible was 8 years ago. But you could do it in many different ways. The idea here is to keep the concept in here. In most languages, you have some kind of operator SDK. For JavaScript, there is one that is really simple, quite small. It is the Kubernetes Operator node. It's a small operator that simply it is going to automate the idea of watching resources. I mean, what is a controller? It's a pod. It's a program you are running. And this program calls the Kubernetes API and says, hey, I am going to watch this resource, and this resource. And when something changes in these resources, I am going to do something. They are basically reconcile loops, as I said. So using this Kubernetes operator node, I have a method in it where I am going to list the resource I wanted to watch. If I wanted to write it from scratch, I would only need to call the Kubernetes API and doing some manual watches. So let's begin the live coding part of all that. Wish me luck, please. Let's close everything. Well, I have here my Kubernetes operator called Gopher Operator. And this is a very simple operator using this API. Why this one? No, I only want, no, nothing like that is needed. And now needed, my operator. Okay, let me begin with something really, really simple. I want to have an operator that watches all the pods that they are on my system. I can create here a new work in progress type script. Up. Well, I am going to use the operator framework for JavaScript, and I am going to create a Gopher operator. As I told you, they give us an init method. And this init method, we are going to tell it which resources we want to watch. I tell it to watch the resources of type pods. They use the standard notation for Kubernetes, the common standard APIs, that's why it is an empty string, the V1, and the object pods. So when I write that, every time a new pod is created, modified, or deleted, my operator is going to get called. And what I can do there, but for example, yeah, I could do new pod found, and I could give, for example, the metadata one name. Yeah, why not? We are going to get the name of the pod. It's a good beginning. This is my first operator. It is already an operator. It watches. There is no custom resources because simply it's an operator that works with standard Kubernetes objects, pods. We can begin to do it. So, exit. Gopher operator, npm build, npm run build. Work in progress. And my operator is working. This is the magic part of writing things for Kubernetes. You can test, when you are writing operators for Kubernetes, you can test them in local. Because most SDK for Kubernetes in JavaScript, in Go, in Java, in most languages, they are agnostic of the connection. If you have defined your kubeconfig, they are going to use it. And if you deploy them in the cluster, they are going to use the service account you have chosen in the cluster. So all the connection part is made by the SDK, by the Kubernetes SDK. So here, they have connect to my cluster, and they have all the pods of my cluster, not only in the default namespace, but also in the technical namespaces. And if I delete a pod, we are going to get another message, my pod is deleted. That's an operator. If I deploy it in the cluster, it is going to keep its life in the cluster, logging every time a new pod is down. Well, I have my first operator, not the one I wanted, but it's a first step. Now I want this operator to get only the random Gopher pods, not the other ones. I only want to watch the random Gopher pods. Yeah, we can do it rather easily. We can simply filter. For example, up. The only thing I have added is, okay, if it is not a random Gopher, I don't want to know. I can do anything I want in the body of my watch. So I get notified of every pod, but I'm only interested in the random Gopher. And, okay. No, I think I have forgotten. Yeah, metadata match. Ah, it is not this one. It's work in progress. 1, 2. 1, 2. I only have the random Gopher. And now, I want my controller, as I told you, to get the identity of the drawing that every pod is carrying. Every pod is carrying a different Gopher. I want to know which one they are. Well, my controller is a pod. They are going to be able to call the other pods, to call them in HTTP. I can do it using directly the Kubernetes API. First thing, when I want to call the Kubernetes API directly, the operator framework I have there, it isn't going to give me help, so I have to go lower level. So I am going to ask the Kubernetes SDK, not the Kubernetes Operator SDK, but the Kubernetes SDK, to give me the credentials of the cluster. With the JavaScript SDK, it is rather simple. Wait a second, there is always an import that makes my life a bit more complicated. But that's boilerplate. So I am going to say, OK, I recover the kubeconfig object, and with the kubeconfig object, I can get the HTTP options version of the credentials. OK, I am going to get the certificate authority, the certificate, and the key. The elements I need, the security elements I need to put in my request to be able to call the API. There is an equivalent of that in any other language you can use. And when you have that, you will be able to, I am going to take the whole one, I am going to explain it. It is going to be easier. So when I have the credentials, if it is a random Gopher, I am going to call it. I am going to call to the Kubernetes cluster API, namespace, the by default namespace, the pod name, and I'm going to call the proxy endpoint. The proxy endpoint in the Kubernetes API allows me to call directly in HTTP a running pod. So I'm going to call the running pod for every pod and asking the /gopher/name endpoint. And I am going to get the response. And then, when I have that, I will be able, for example, await the response text. Gopher. Why you don't want Gopher is a string? Okay, I need to initialize it here. Why not? Gopher, and Gopher. And if I haven't done anything weird, now the first part of my task is done. For every Gopher pod, I know which Gopher they are. In this first part, my controller is simply getting information of resources inside the cluster. Now it's the second part. I need to call an external API and send this information. And for this part, we need to create a custom resource definition. We need to explain to Kubernetes that my API is somewhere. So I am creating, I have 10 minutes. It can be done. Look at that. I am creating a custom resource definition. That's a custom resource definition, a template of my Gopher API. For me, in a Gopher API, there are only two things that my cluster needs to know, which is the endpoint, where I've deployed it, and which is the API key, because I have put an API key in to be sure that only my cluster can send. So I explain, okay, in this kind of objects, the important properties are endpoint, API key, and both of them are required. I have deployed that in my cluster, kubectl, apply-f, manifest, Gopher, API, CRD, YAML. And then I can create a custom resource. A custom resource is an instance of my API with only two properties, the endpoint and the API key. But first of all, I need to connect. So I'm going to connect to my instance and launch the API, tmp Gopher API, npm run start. And here I have the API key. I copy that. I put that. And I am deploying the seer, the object defining my API. Now, I only want to say, hey, when you have the Gopher name, you are going to build a Gopher object with the properties the API want, a name, an ID, and especially the URL for the drawing, and send that to the API. Work in progress. Oh, the complete operator, we can do it. We can do it. So, what we have changed? First, I have told my operator to also look for the Gopher API objects in my cluster. The lost in Brittany dev, Gopher APIs. And when they find a Gopher API, they get the API key and the endpoint. That's the first part. And then, for the pods, the same thing that before. And when we have the pod name, if we have in API defined it, if there is an endpoint, then we send the Gopher. If it is a new pod with post, if it is modified with put, and if it is deleted with delete. And this send Gopher, it is going simply to call my API than the right endpoint with the right API key, and we are going to send them a Gopher object. And this Gopher object, we build it, get Gopher info, yeah, we build it. We have the Gopher name, so we give it as ID the pod name, The name is the Gopher name, display, and especially we craft the URL from the Gopher name in the Aurélie's repository. We create the object, we send it to the API. So, run build. Work in progress. Wow, I have just sent all the Gophers there. This is in my API, the Swagger part, and it is interesting because in the Swagger part, I can try. I execute. Oh, yeah, I have sent a lot of information, all of those nice Gophers. That means that here, yeah, I have the random Gopher with the ID of every pod, and for every pod, if my 5G is a bit fast, you will see the drawing corresponding to the Gopher identity of every pod. And what happens if I kill one of the pods? For example, let's say I kill the 42H4Z. Yeah, that's the kind of things that I shouldn't be doing in real time like that. But it is funny. Export, kubeconfig, because, hey, I could stop here with a success, and I am going to risk making things more complex. Donc, kubectl get pods. Let's kill this one, please. kubectl delete pod. So usually, if everything goes right, the pod is going to die. The terminating, I haven't done a good terminating on my pod, so I try to kill it in a gentle way. That's why Kubernetes waits a bit, but when it will get killed, it is going, I am going to get the message and send that to the API. And yeah, usually it is killed. So that means that here, hey, malformer event. I told you I have a problem. Oh, no. Well, I have a quick problem in my thing, but the idea is that I listen to the events. I haven't listened in a right way to the delete event. I listen to the event. For every event, I get the information, and I can do whatever I want. Asking the cluster resources for more information, or talking to external resources to managing external resources. It is a really silly example, because I really wanted to show you some cute Gophers, but it's a serious matter. You can use your Kubernetes in order to pilot other parts of your infrastructure. You can easily interface Kubernetes with other parts of your infrastructure. Kubernetes Operators, yeah, it can be a bit scary, but if I can do something like that in 20 minutes, imagine what you can do after several days of work on that. The possibilities are really enormous. And if you are an editor, for me, you should begin to think about writing your Kubernetes operator for your software. Because it is making a Kubernetes operator for a product, make it really easy to adopt it in the Kubernetes community. People don't want simply to have an Helm chart to deploy your software anymore. Right now, people want your software to be automatically intelligent operated by the cluster. So if you want your product to get traction, in the Kubernetes ecosystem, it is a good idea to do the effort and creating a small operator to help people to use your product in the Kubernetes ecosystem. And just in time, I have finished. I hope you have liked it, and I hope some of you are going to try to write your operator in the next days, in the next week. Thank you very, very much.
Yeah, we are a bit tight on questions time, but let's try to do some quick ones. They're asking like, okay, you showed this with TypeScript, JavaScript. Are there any benefits of this over using the Golang libraries? And
in Golang, it is very simple to do the same thing, but more verbose. You need to build all the structures. So my program will have some 100 lines more of Gopher extractor, API extractor, and all that. Doing it in this way makes things smaller. That was the only reason.
Yeah, but in terms of runtime or complexity, it's more or less the same, no? And then, like, do you, like, not sure if you can disclose that, but at OVH, do you use your custom operators for things? Do you have some of those?
Yeah, we have created custom operators to manage part of our infrastructure. For example, our Kubernetes load balancer is managed directly by custom operators. And we have created open source operators, especially for the Harbor project. The Harbor operator is made by us because we use it for our private registry. Right. So they are very important, and most serious Kubernetes actors are using them right now.
All right, good. And yeah, like people are asking, like, if you could provide some other use cases that you could use operators in your daily, aside from the one you mentioned about if you are building your product, right? But say you're an e-commerce or like any other business, like you're going to say anything, but do you?
For example, if you have any data product, it will be nice if using data in Kubernetes, that means that you have persistent volumes, that you have external disks. Having an operator make the day-to-day of that easier. You can define your backups. You can define the controlling the capacity of your disk. You can define how you are going to do eventually sharding things. That's another use case. Or for products that are complex to operate, like Kafka, a Kafka cluster on Kubernetes. Operating Kafka, you know it, my friend. It isn't
people
easy.
People buy AWS offerings.
If all the day-to-day tasks of your Kafka operations are done by Kubernetes, you can center yourself on the performance, on the efficiency, on things that really matters, and not in how I put how I look for that topic not to be too big. No, okay, let's Kubernetes do the day-to-day things, and they center you in things that matter.
All right. Thank you very much, Horacio. It's always a pleasure to have you on stage.
Thank you, man.